All right, guys, we're going to do a super quick review of prime and composite so that I can teach you my most favorite thing in the world to do. It's called prime factorization. So we'll get to that in a minute. Prime versus composite. Well, first of all, if you know anything about me, you know that I love prime numbers. Woohoo! Yay, love them. And composite numbers, ew, yucky, just boring and not fun. So just a reminder, prime numbers. The definition of a prime number is that it has exactly two factors, 1 and itself. And we know that any number times 1 times any number is itself. That's where this comes from. And so what I think about it is prime number is any number with exactly two factors, 1 in itself. Those are the bookends. So I'll give you an example of a prime number, the number 5. I know that 1 times 5 is 5. Those are going to be my bookends. So you can see here we have our bookends. And we don't have any books inside there. There's nothing times 2 that makes 5. There's nothing times 3 that makes 5. And nothing times 4 that makes 5. So the only factors are 1 and 5, just the bookends, prime number. Love the number 5. My favorite one, 13. All we have for the bookends are 1 and 13. Even though there's a lot of space in here, there's nothing times 2 that makes 13, nothing times 3 that makes 13, nothing times 4 that makes 13. I can go all the way through all the middle between the 1 and 13, and there are no other factors. 13 is a beautiful prime number. Now, there are a lot of prime numbers, but I'd love for you to try and memorize the first few prime numbers up through my favorite. You can make a song if you need to. 2, 3, 5, 2, 3, 5, 7, 11, 13. I don't care. Make something up. But if you take a look here, anything that's highlighted in blue is a prime number. And you can see there's definitely more composite numbers in the world than there are prime numbers. That's why prime numbers are so special. The only even prime number on that entire list is the number 2, because the bookends are 1 times 2 is 2. There isn't room for any other books inside there. And so it's awesome. And 1 is neither prime nor composite. It doesn't count as either. So 2, 3, 5, 7, 11, 13. I don't know. Find something to remember. I'm sure you guys are more creative than I am. Now, composite numbers have more than two factors, so we have more than just the bookends. For example, the bookends for 10 are 1 times 10 is 10, but you can see we also have 2 times 5. As soon as books can fit inside those bookends, it's just a lame composite number. There can be odd composite numbers. A lot of people say, oh, if it's even, it's composite. If it's odd, it's prime. But you can see the bookends here are 1 times 9, but we know that 3 times 3 is also 9. So it's just a lame composite number. So anything that's in white, with the exception of the number 1 that doesn't count as either, is just a lame composite number. There's lots of them. And here's the thing. I love prime, can't stand composite. But there is a way, something called prime factorization, where you can take any lame composite number and you can rewrite it using only prime numbers. It's phenomenal. You can turn any lame number into an awesome number. Let me give you an example. 24 is definitely a composite number. So I like to think about this like a tree. I'm going to take 24 and I'm going to branch 24 out into 2 parts. So I need to come up with 2 factors of 24, 2 numbers that multiply together to make 24. Well, I know that 6 times 4 is 24. So I need to ask myself, are either 6 or 4 prime? Well, I know that silly song, 2, 3, 5, 7, 11, 13. Okay, so I'm going to get rid of my face. I feel like it's a distraction. Boom. Oh, that was not getting rid of my face. Let's try that again. There. Okay. Yeah, I don't know how to do that. Okay, maybe I'm there. I don't know. Maybe. Who knows? Okay, so right now, here are my prime numbers. Neither 6 nor 4 are prime, so we need to keep branching these out. I'm going to start over here at the 6. I know that there's 2 numbers that can multiply together to make 6. I know that 2 times 3 is 6. So I first need to ask myself, is 2 a prime number? The answer is yes, so I'm going to circle it. That branch is done. Is 3 a prime number? Yep, it's right there. So 3 is done. I'm going to circle it. Remember, I'm looking for prime factorization, so I'm going to end when I hit those prime numbers. So I don't have any branches here to continue. Those branches are done. They've kind of hit their fruit, or whatever you want to say. Or this branch is still going because it's still composite. So I'm going to branch that out again. And what do I know? Well, I know that 2 times 2 is 4. So I know 2 is a prime number, so I can stop there, and 2 is a prime number, so I can stop there. I don't have any branches that are still going. So right now I'm going to take my answer and I'm going to write it out, listing all the prime factors in order from least to greatest. So I can see a 2, so that takes care of that one. I can see another 2, that takes care of that one. I can see another 2, that takes care of that one. That's all my 2's, and I also have a 3. So that takes care of all of them. So you can see, guys, I have 4 factors, and they're all prime. 2 is prime and 3 is prime. And I can prove to you that this is still 24. 2 times 2 is 4. 4 times 2 is 8, and 8 times 3 is 24. Now, there is another way that you can write this. Because I have 3 2's multiplied together, repeated multiplication, I can rewrite this and say this is the same as 2 to the 3rd power times 3. So that's just another way to write the same thing of prime factorization using little e. All right, I'm going to go a little bit faster here. 2, 3, 5, 7, 11, 13. Stick some commas in there. Okay, so we know we're looking for those numbers, and that's going to be the bottom of our fruit. So 20 is LAMO composite, so I'm going to branch it off. There's different ways I can do that. I can do 2 and 10. I can do 4 and 5. It doesn't matter. You're going to end up with the same results. Let's do 4 times 5. So I'm looking. I know that 5 is a prime number. It's right up there in my list, so that branch is done. But 4 is not a prime number, so I'm going to branch that out further. I know that 2 times 2 is 4. And I know 2 is prime, and I know that 2 is prime. And all my branches are done. So if I'm going to write this out, I see a 2, that's that. I see another 2, that's that. And I see a 5, that's that. So 2 times 5 is the same as 20. But lucky for me, all of these are prime numbers. I'm writing the number 20 using only prime numbers. I know this is true because 2 times 2 is 4, and 4 times 5 is 20. Remember, another way to write this exact same answer, since I have 2 2's, I can write 2 to the 2nd power times 5. Those two things mean the same amount. All right, let's try this one. 40. Let me just write them down. 2, 3, 5, 7, 11, 13. All right, so 40 is an ugly prime number, so I'm going to split this up. I can do 4 times 10. I can do 5 times 8, whatever you want to do. I'm going to do 4 times 10, since 4 times 10 is 40. Neither of those are prime numbers, so I'm going to start with the 4, and I'm going to branch that out. I know 4 is the same as 2 times 2. 2 is a prime number, so both of those are done. That side is all done. For the 10, that is not prime. It's not on my list up there. So I know that 2 times, did I already do 40? This sounds so familiar. 2 times 5 is 10. 2 is prime, and 5 is prime. So I'm done with all my branches, and I end up with 2 times 2 times 2 times 5. And to prove that this is 40, 2 times 2 is 4. 4 times 2 is 8. 8 times 5 is 40. I'm going to go back. I feel like I just had deja vu and I've done that one. Nope, just kidding. That was very similar. Okay, so another way to write that, just as a reminder, is when you have many of the same number, like in this case we have the number 2 3 times. This would be 2 to the 3rd power times 5. All right, let's try another one. 64, it's a big one. So 2, 3, 5, 7, 11, 13. Okay, now obviously there could be more, but we're going to start with that. 64. Flat, flat, floor, floor. 8 times 8 is 64. Neither of them are prime factors, so I'm going to now take 8, and I know that 8 is the same as 2 times 4. 2 is the end of that branch because 2 is prime, but 4 I can branch out further to be 2 times 2, and those are both done. Now I have to branch off over here. That would be 2 times 4. 2 is done. Oh boy, but 4 is going to branch off 2 and 2. It is super important you circle those prime numbers because you got to see them at the end and make sure all your branches are done. And if you look here, I can see that I would have 2 times 2 times 2 times 2 times 2 times 2. Or I can say that this is 2 to the, let's see, 1, 2, 3, 4, 5. 2 to the 6th power. Again, I can write it all out. I can do 2 times 2 times 2 times 2 times 2 times 2. And to prove to you this is still 64, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64. So 2 different ways to write the same thing. Okay? All right. Last one, 25. I know 25 is not a prime number, but I can break it down into 5 times 5 is 25. 5 is prime, and 5 is prime. So I can say the prime factorization would be 5 times 5. I'm writing the number 25 with only prime numbers, which is awesome. I can also write this as 5 to the second power. Now, real quick, I just had a thought. I'm going to skip 100 for a minute. Let's say that you tried to start with a prime number. Let's say you started with beautiful 13. Since there are only 2 factors that make 13, the only time I can branch it off is to say, well, 1 and 13. If at any time that is it, that's all you can do, well, that's the definition of prime. So this one's already prime. Okay? Let's go back to 100. 100 is my favorite. I can do so many different combinations to get 100. I can do 2 times 50. I think I'll do that one. I can do 10 times 10. I can do 20 times 5. But I'm going to do 2 times 50. 2 is a prime number. 50. Gosh, I know 5 times 10 is 50. Well, 5 is prime, but 10 is not. So I'm going to do 2 times 5. 2 is prime. 5 is prime. So I can see here I have 2. That's that one. Times 2. That's that one. Times 5. That's that one. Times 5. To write this using little e, I can say this is 2 to the second power times 5 to the second power. All right, guys, that's prime factorization. I did it in under 12 minutes, so I got to say goodbye or else I'm going to go over 12 minutes. Hopefully this makes sense. See ya.